Hello, geometry. This is the last lesson in chapter 6. After the triangle lesson, or here, chapter, we're going into quadrilaterals and more polygons and more sides that we can even look at. So this last one is called Inequalities in Two Triangles. It basically is one theorem called the hinge theorem. It says if two sides of one triangle are congruent to two sides of another triangle, what can you say about the third sides of the triangle? Okay, so we have this situation right here going on. I have two sides, an orange and a purple, and two sides, an orange and a purple. Okay, so one of them is connected with a green piece, which is, if I overlap these a little bit, you can see that it is shorter than the yellow piece. Put it this way. So what we're going to look at here is if I have two sets of congruent sides and this side is shorter, what do you know about the angle formed by the orange and purple pieces here? What's the relationship between them? Okay, so think about it. If this green is shorter, okay, what happens to that angle, as you get shorter pieces on that side? Okay, I can take this off and think about, okay, if I use shorter pieces, what is happening to this angle here? It's getting smaller. So the shorter the third side, the smaller that angle opposite of it. Okay, just like we had with the triangle inequality theorem. If I make it bigger, the longer the side, the larger the angle there. So we would know that the angle formed by this green triangle opposite the green side is going to be smaller than the angle formed by with the yellow side, because the yellow is greater than the green. That is what we refer to as the hinge theorem. Okay, they have a nice diagram here in the book for the hinge theorem. That's why they call it a hinge. A gate is swinging. The distance between the posts is fixed, and the gate is swinging open, and as that B to C, as it gets longer, angle A is going to get bigger. Angle C is consequently getting smaller in that case, so is angle B. So watch angle A, as the door swings open, angle A is getting bigger. Okay, that's what we refer to as the hinge theorem. We also have the converse of the hinge theorem, which basically works the other way. Okay, so when we look at some of these things, so we have the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angle has to be an included angle, that means it's the one between them. So here's your two sides and the one between them. Of the first is larger than the included angle of the second, so 88 is larger than 35. Then the third side of the first is longer than the third side of the second. So WX is greater than ST. So we have two sets of congruent sides. So we need two sets of congruent sides. We have to compare the included angle. So compare the included angles. One's going to be larger than the other. If not, you have congruent triangles. The larger angle will have a longer third side. The larger angle will have a longer third side. Okay. My Desmos example is right here. Okay, you see 79 is bigger than 72. So I have a 2-inch side, a 4-inch side, or 4-unit side, 2 and 4 on the other one. 79 is bigger than 72, so this third side, 4.13, is bigger than 3.89. Okay, and I can move that, I can make that even bigger, it gets even bigger, I can make it smaller than 72. Now 3.35 is less than 3.89. Okay, let's see how I made that. I just used circles. Okay. So the converse of the hinge theorem is also true, so you could write a biconditional between these two, if and only if, between the two hypotheses and conclusions. So if two sides of one triangle are congruent to two sides of another triangle, and now this takes the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So given the three sides, we have two congruent sides, and here's my third side. So since 12 is greater than 9, the measure of angle C is greater than the measure of angle F. Okay, so you have to compare those two sides there. So this one starts off the same again. We need two sets of congruent sides. You could even put the word corresponding in there. Congruent corresponding sides. Two sets have congruent sides. Two sets of congruent sides. And now for this converse, we will compare the lengths of the third sides compare the lengths of the third side. The longer third side will have a larger angle opposite of it. The longer third side will have a larger angle opposite of it. Okay, so our fun examples here, easier ones. We'll get to some proofs a little bit. It says in exercise 1 through 9, complete the statement with the less than, greater than, or equal to, explain your reasoning. The explaining the reasoning will be the hinge theorem or the converse of the hinge theorem. Alright, so what we have here, they want us to relate BC with EF. So we have a set of congruent sides. A second set of congruent sides, AC is congruent to DF, and 35 and 45 are the included angles. So 35 is less than 45. So 35 is less than 45, so BC has to be less than EF. Okay. This one would be the hinge theorem, because they gave us the angle and we related the sides. Okay. So 4, 5, and 6 are going to be the converse. You notice how we're relating the angles based off the sides. So angle 2, BC is right here, EF is right here. We have a 95 and a 20. So 95 is opposite BC, 20 is opposite EF. I write them underneath. The inequality for the numbers has to be the inequality for the sides. Okay, write the numbers underneath their corresponding sides, the one's opposite of it. The inequality for the numbers has to be the inequality for the sides. So BC, there's a 90-degree angle there. EF, there's a 90-degree angle there. Those are equal, so those are equal. Okay? Hinge theorem, reason all the way throughout. Number 4, 5, and 6. Notice they're asking for relationships of the angles, so our reason for all of these will be the converse of the hinge theorem. Converse of the hinge theorem. So, measure of angle A and measure of angle D. So we have two sets of congruent sides. You know they are the same. So we have the same opposite side, so these two angles have to be equal. This is the side-side-side congruence theorem. So these triangles are the same size, same shape. Okay, not drawn to scale. Angle A corresponds to 14. Angle D corresponds to 16. So I'm going to put 14 and 16. 14 under the A, 16 under the D. 14 is less than 16, so the measure of angle A has to be less than the measure of angle D. Okay, A corresponds to 9. Hopefully you can already get this pretty quick. D corresponds to 2, 9 and 2. 9 is greater than 2, so the measure of angle A has to be greater than the measure of angle D. 7, AB and AC. So here's AB. AC is over here. So AB matches up with a 145-degree angle. So when I go across it, 145 is that angle right there. 135 is opposite AC. We do have two sets congruent. That's the included angle. They share DA. 145 is greater than 135, so AB has to be longer than AC. Okay, AB and CD, they're opposite equal angles. So we have side angle side congruence theorem. Side angle side congruence theorem. They have to be the same length. Measure of angle 1, measure of angle 2. So angle 1, do we have side, angle, side? Yes, side, angle, side. Measure of angle 1 is opposite 19. Opposite to 19. Angle 2 is opposite to 17. 19 is greater than 17, so angle 1 has to be the bigger angle. Here come the proofs. Okay, write a proof. So what you're going to have, what your proofs will be like, is ordering them. Let's go down there. Right, this question right there. It says order the proof. So it has these, and you just can kind of move them around, put them in order. I would always start with your givens. Okay. And then you're going to have your reasons that have to follow some of these things. So anything that says so or therefore, that's usually something that's going to be a conclusion. So these statements need to come first. By the reflexive property is when you have something that matches itself, and by the hinge theorem. Okay, so you can kind of follow it, that format right there, kind of gave that one to you. The given should go first. The reasons should precede the statement. So the statement will follow the reason. Okay, you do have another one you need to do there. Okay, but write a proof. So here's our givens. That off there. So xy is congruent to yz, and wx is greater than wz. That's all given. Okay, we share this. YW is congruent to WY. That's the reflexive property, similar to the one we just saw. So since we have side, and we know WX is greater than WZ, this is the longer than this one. WX is longer than this one. That means the measure of angle WYX has to be greater than the measure of angle WYZ. And that is the, okay, they're giving us the sides, we're relating the angles, so that is the converse of the hinge theorem. And that's kind of the setup there. If you're doing this on the assignment, you would say xy is congruent to yz is given, wx is greater than wz is given. By the reflexive property, this is true. So, or therefore, by the converse of the hinge theorem, measure of angle wyx is greater than the measure of angle wyz. Okay, so that's how that kind of plays out with that. This would be the same thing, except now they're relating the angles. DAC is larger than ACB. So it's larger than that. So again, these are the angles we're checking here, angle 1 and angle 2. We have our givens. We have AC is congruent to AC, again by the reflexive property. So on the assignment they say by the reflexive property, AC is congruent to AC. The givens would go first. And then this would be by the hinge theorem. We know DC is greater than AB, what you want to prove. That would be the last statement. Loop a rubber band around the blades of ends of a pair of scissors. Describe what happens to the rubber band as you open the scissors. I don't have a rubber band, but you can see here, here's my scissors. Rock, paper, scissors. Daniel learned that here recently. Okay, if I put a rubber band on there and I open it up, the bigger the angle, the longer the stretch. Okay, so if I get a big angle on my scissors, that third side is going to really stretch out. So that's kind of what they're talking about. That's how it relates to the hinge theorem. The larger the angle between the two sides of the scissors, the longer the third side. The longer the rubber band is stretched. Okay, starting from a point 10 miles north to Crow Valley. All right, Crow Valley. Yeehaw. A crow flies northeast for 5 miles. We're 10 miles north of Crow Valley. Another crow, starting from a point 10 miles south of Crow Valley, flies due west for 5 miles. Have you ever known a bird to fly straight in any direction for that much of time? Or maybe those birds would be flying south. Which crow is farther from Crow Valley, and explain? So here is going to be good old Crow Valley. And we have a point 10 miles north and 10 miles south. So 10 miles going north, he's going to fly for 5 miles northeast. So this angle right here, if it's going northeast, this angle is going to be 135 degrees. 135 degrees, because we have the 90-degree angle plus 45. So 90 plus 45 is 135. This one is flying due west. Here's west. Know your directions, please. Never eat sour watermelon. Never eat soggy wheat. Okay, we're flying due west for 5 miles. Notice the side and angle. And now this is a 90-degree angle since we went due west. So which one is further away? It would have to be the one that is on top because of the hinge theorem. 135 is bigger than 90. So crow number 1, the one that flew northeast, is flying farther away. A little bit of common sense with that one as well. Okay, but you'll have a question. You'll kind of have to set up some of those diagrams there, get the angles figured out. But if you have questions with it, just ask. But good work with Chapter 6. We'll start reviewing and get the test in here shortly and move on to polygons in Chapter 7. See you in class.